Welcome to my review of the ZWO ASI533 color camera. I've used this camera for the past year with a couple of different telescopes, and I'm going to give a review of my experience with this camera. The two scopes that I used were a 70mm triplet refractor, the StellarVue SV70T, and the Lxstream Edge HD8. All images have been taken from a Bortle 4/5 with varying phases of the moon. As you can see here in these pictures, the main thing that separates the 533 from a lot of other cameras is that square sensor. I found that square sensor works very well on social media. It matches up well with Facebook and Instagram and other places like that. If you want to do desktop backgrounds with it, the square doesn't work too well, but you can address that by doing two-panel mosaics. So let's take a look at a couple of RGB images or broadband images that I have taken. These next three images were all taken with the ZWO Luminance Filter. If you were to use a simple IR UV cut filter, I'm sure the results would look very similar. So this is unprocessed, unstretched. This is what a stacked image looks like. This is from Deep Sky Stacker. It does include dark frames, flat frames, and dark flats. I'll go ahead and stretch it so we can take a look at it. And so again, unprocessed, here's what it looks like. If we take a close-up look, you can see that there's very little noise in this image. Now this is 160 3-minute subs. I've noticed with this camera that once I get over 100 subs, the noise really cleans up when shooting broadband. And when you have data like this, it's this clean to start with, it makes your post-processing much easier. So we can take a look at the final image. And yes, I did a mosaic, so 2 panels. It's about 8 hours on each panel. And color looks great. I was really impressed. This was actually my first one-shot color camera. I've started out with mono, and honestly, the color that I was getting and how easily I was able to get this data blew me away. This was my first shot. So we'll take another look at a different one. Now, I thought this would be interesting. This is a piece of M31. On the left side, we have 2 hours and 20 minutes worth of exposure. On the right side, we have 6 hours and 40 minutes of exposure. So I thought it'd be interesting to see the difference in the noise. And so you can see the 6 hours, how much smoother. I mean, for 2 hours and 20 minutes in a Bortle 4, I mean, this doesn't look bad at all. But adding a few more hours really cleaned it up. We'll slide over to a darker portion. That's usually where the noise will show up the most. And you can see a difference. Now, what's interesting is even though I used darks, you can still see a hint of hot pixels in there. And that's what I've noticed with this camera, that as you build up more and more exposure, these hot pixels go away. Now, maybe I just use Deep Sky Stacker to stack this, so maybe if I had stacked in PixInsight, or I took more care on cleaning this out, these wouldn't be here, but still, it's not bad. You can see stacking artifacts here, but otherwise, pretty good. And this was also another 2-panel mosaic. And that's what my final image looks like. I thought M45 would be a good example for this. Oops. Now, I do think I believe, if I remember correctly, I used 300-second exposures on this at gain 0. But I think it was too long because these stars, these medium-sized stars to me look bloated. But I thought this would be a good example to see if we're getting any kind of halos, which is often a problem for a lot of setups. And as you can see here, really not any halos. Maybe a hint of it over there, but I mean, these are all bright stars. Again, with that ZWO Luminance Filter. And this is unprocessed, just auto-stretched. Just shows us what's in there. Again, noise is very well kept in check. A lot of the pictures that I've taken with this camera, I end up not even applying noise reduction to. And there's a processed image. So next, let's take a look at some narrowband images that I took. Now, as I mentioned before, I actually started with mono, and I had an ASI-1600, so I have a full set of filters. And my ASI-1600 died and has been sent back to ZWO for repair. So while waiting on that, all I had was this 533, and I was itching for some narrowband imaging, so I thought, what the heck, let's just see how it goes. So what we have here is the Veil Nebula, and this is with an Astrodon 5 nanometer HA filter, and not very pretty. On the left here, we just have 36 minutes, and on the right, we have 5 hours. And so you can see a very noisy here, very noisy image. I mean, we are getting some structure. Keep in mind that with this being a one-shot color camera and HA being red light, that this is only hitting one quarter of the pixels on the camera. Take a look at the 5 hours. I mean, it's smoother. Definitely have some data in there. I have no doubt a mono camera would have more data and probably much cleaner. So it's still pretty noisy. If you're curious, let me get the screen transfer function here. If we lock our channels, there's all that red. And let's take a look at the O3. So the O3 filter that was used was an astronomic 6 nanometer. And I think I took this image with the moon out. The gradients are pretty bad. You can see it right here. And I'm pretty sure this gradient is the moon. And again, I mean, we're getting something in there. We are definitely getting something. 5 hours worth of data here. If this were RGB, all this noise would be completely smoothed out. But now, even with mono cameras, your O3 and S2 subs are going to be noisier than your HA subs, but I have to think that this would look better with mono. But we got something. And I also did a 2-panel mosaic. I find myself doing a lot of those with this chip. And that's what the final image came out to. So, I mean, it's not bad. It's a little bit on the grainy side. It's a little noisier than I would like. I mean, a lot of this was captured with a bright moon out. And, I mean, you know, one-shot color camera. It can't really... I think this honestly came out better than I thought it would. So I thought I'd give another narrowband target a try. And so I went after the crescent. And so we got 13 hours of HA, 14 hours of O3. I really wanted to try and bring that O3 shell out. So I mean, it's not too terrible. It's still noisy. It's still grainy. You can see a little bit of the shell here. Again, these are unprocessed, just stretched. And the final image is this here. So I do think that if I was using a mono camera, I probably would have got more. There wouldn't be as much this darkness. This area would be more full. But I mean, it's okay. It exceeded my expectations, but I don't really recommend this as really a viable option. I mean, I guess you can if you really want to, but there's a better way to do narrowband with this camera, which I'm about to show you. Okay, so now let's look at some Lxstream data. Now, for those that don't know, the Lxstream filter is one of many multi-band filters available for one-shot color cameras. The Lxstream passes hydrogen alpha and oxygen 3 with 7 nanometer band passes at the same time. So the advantage here is that all of your pixels are getting some light. The HA is hitting your red pixels, and because O3 is kind of a greenish blue, it's hitting both your green and blue pixels. So you're getting all that at once. Now the trick is Lxstream works best with oxygen-rich targets, in my opinion. So the first target I went after with the Lxstream was the Cave Nebula, and I think that was actually kind of a poor choice for a first test of this filter. Now this is the raw unprocessed image. You'll notice that now this is 17 hours, right? So it's still nowhere near as smooth as RGB. There's definitely some noise in there. I think one of the reasons I pushed it so hard at 17 hours was to try to get rid of this grain, but it was always there. And there just isn't a lot of O3 in this region. It turns out this region is a very nice RGB object. I think the Cave Nebula pictures I've seen in broadband look fantastic, and I would actually recommend going broadband with this. I did get some broadband data. I tried to mix the HA, pull the HA out from this and mix it with the RGB, and I had some mixed results, but then the moon kept coming out, and so I ended up just sticking with the Lxstream on this. And here's the processed image. So I mean, it looks good. It came out okay. This kind of fiery red tone, this is a common trait you see in a lot of Lxstream images. So I mentioned oxygen-rich targets. So this is Thor's helmet, 18 hours. This is just straight Lxstream data, nothing special, and it came out pretty darn good. You can see here now the noise is much better. And you have all this wonderful O3 in here. This image was taken with my Edge. I think every image I've shown so far has been taken with that 70mm refractor. And so this is the first image I'm showing with the Edge, Celestron Edge HD8. And here's the processed image. And another one, this is processed. This was kind of a quick shot that I took. It's just 3.5 hours straight Lxstream, nothing else in there. No noise reduction was used in this image at all. So I mean, it's got some grain. It probably can stand to use some noise reduction, but I didn't want to mess with it. Kind of kept it in its natural state. And so this is where I think you do really well with this camera and a dual band filter like the Lxstream, because you get that HA and that O3 and you get some really nice looking images. The colors are balanced well on these types of targets. So the last couple of images I'm going to share here are examples of achieving the Hubble palette with a one-shot color camera. Now this is really the domain of a mono camera, but you can do it with one-shot color. So here's the Rosette Nebula that I took, and this is using the Lxstream filter. So we have HA and O3. Now to do Hubble palette, we also need to get S2. And I have an S2 filter, and so I shot some S2. And so here's 6 hours of S2 on the Rosette that I used with the Lxstream. And the result was this. So yeah, I mean, that I think is a pretty decent looking Hubble palette rendition of the Rosette Nebula. So it is definitely a possibility to do this with a one-shot color camera. Again, not as efficient as a monochrome camera, especially since with S2 being red light, again, you're running into the scenario where only a quarter of your pixels are taking in data. But the fact that you can get all of your pixels engaged while using the Lxstream filter, you know, that helps you out on the inefficiency game. You're still going to need to get more hours of integration than you would with a narrowband with a mono camera, but it's certainly doable. So if you've already got a one-shot color camera, where you think you're going to do, you would like to try the Hubble palette occasionally with the one-shot color camera, then I think this is actually a viable alternative. If you plan to shoot a lot of narrowband and you haven't purchased a camera yet, you definitely want to think about going mono. If you already have the one-shot color camera, you can do this. And if you think you're going to do more narrowband imaging, then maybe you may want to grab that mono camera after all. And on the plus side, you'd already have the S2 filter if you want that route. Here's another example. Jellyfish. 18 hours of Lxstream data and 16 hours of S2 data. So, I mean, that is one of the things with it being less efficient. You really got to pile on the time to get good data out of there. But the end result, I think, is pretty solid. It's not bad. One-shot color camera, Hubble palette on the Jellyfish. So, in summary, what are my thoughts on the 533? I think it's actually a very good camera. ZWO kind of bills it as a beginner's camera, and it's definitely a good camera for a beginner. It comes in at a very good price point, and it's very forgiving in terms of the need for calibration files. There are a lot of folks that say you don't need calibration files. I'm still in the camp that you still benefit from getting your calibration files. But if you get enough subs, you can probably get away without them. And then, of course, with filters like the Lxstream available, you can definitely dip your toes into some narrowband imaging. I'd say as far as pros go on this camera, you're getting some of the latest tech. This is using the same technology as the larger chip cameras, like on the ZWO line, the 2600 and the 6200. And the pixel size is also versatile. As you saw, this picture right here is with that 70 millimeter refractor with a 336 millimeter focal length. And then I also am shooting out of a Celestron Edge HD with an image scale of 0.53. And all of this is on a EQ6R mount. In fact, some of these 70 millimeter shots were taken on an AVX So it's possible to get solid results with this camera at a good price. So yeah, 2 thumbs up for me on this camera. If anyone has any questions about this, certainly feel free to ask in the comments below. If you like this this type of video, let me know. Subscribe. I have a couple of others in mind. Thinking about doing a video showing how I do the processing to get this Hubble palette with this camera, and maybe do a demonstration of how I do the 2-panel mosaics in PixInsight. So anyway, let me know. Otherwise, thanks for watching.